Howdy everyone. Itztli Ehecatl here, and I wanted to just make a follow-up. I made a video about like just an introduction to the calendar correlation, and I think it was pretty successful because a lot of people have been reaching out to me and have been asking me like follow-up questions, and just trying to understand a little bit more. And so I think I accomplished my goal. I wanted to, make a helpful introduction to people. So what I decided to do is just turn it into a calendar series, and I'll just go step by step, and hopefully throughout the series, as you watch them, your questions will be answered. And so that's my intention with this. The thing that I'm going to focus on today is specifically the Alfonso Caso calendar correlation. And if you've read my articles or seen my other videos, you'll know, what it is, but I'm just gonna give you just a little breakdown here. And after I introduce the correlation, I'm gonna get into why it's a it's a terrible correlation. In fact, I think it's probably, in my opinion, it's the worst that is available, which is why it's so frustrating that it's so prevalent. And I'm going to show you a few places in which the Alfonso Caso is prevalent. That way you can learn to kind of identify it, right? And then critique it. And I'm going to do the critiquing work here in this video so that you know why it's so terrible. In fact, they call it, it's a calendar correlation, but it's actually an incomplete calendar. It's actually not even it's not a complete correlation. And I'll show you exactly what I mean and how we know that. And so one of the main, I mean, this is in the United States, all of the scholars who focus on Mesoamerica, they actually use Alfonso Caso. And they use him in their their research and their published articles. And as a result, a lot of research in the United States is based on a faulty calendar correlation. And it's just stunning to me that so many scholars just continue to use it, and they're just putting so much misinformation out there as a result. Now, in Mexico, they don't use the Caso correlation, which is funny because Alfonso Caso was a Mexican researcher, and Mexico does not use it, right? They actually use a correlation called the Tena, Rafael Tena correlation. And so they use a completely different calendar system. The Caso count is used in the United States. And the other one, unfortunately, we have this website here has been around for many years. And this website, azteccalendar.com, a lot of people I notice who are just beginning or don't know much about the calendar, they'll use this. And unfortunately, this one is also based off of the Alfonso Caso, and you can see it right here, the correlation, right? And so most people who are beginners, just trying to find their birth date or whatever it is, they consult this website, and it's completely wrong. And then you have cultural practitioners. This person, Chicome Itzcuintli Amatlapali, sorry, is does some really amazing work. And he's got an Etsy store. And the crazy thing is, everything that he does is based off of the Alfonso Caso calendar correlation. And I'll show you some of his work. And so he's got a calendar, right? And then he's got a tonali reading, and I mean, just really amazing work. Props to him. He's really preserving the culture in like an amazing way, and he's making that available for everybody. But unfortunately, he's following the castle count. Now, the castle count has nothing to do with the Aztec calendar that was in use in Tenochtitlan at the time of the conquest. So as a result, people buying these things, they're thinking that it's, oh, my tonali, based off of the Aztec calendar, but it's actually not. It's not based on anything like that. And I've asked him about it, and he just says, oh, I use it because a lot of people use it, and I think he said like some native groups he thought used it, and so that's why he uses it, right? So it's unfortunate. Maybe somebody can hit him up and just give him this video and show him why it's not a good idea to use this count. But I'm gonna go ahead and just talk a little bit about Alfonso Caso, and I actually have an article that I wrote, and a lot of people have used this article to kind of just guide their studies when it comes to the calendar. And so I'm just going to open this because it has an introduction to Alfonso Caso, so we know, just an introduction of who he is. And so if we scroll down, here he is right here. Actually, that's okay. Here, sorry. He's gonna be after here. All right. So Alfonso Caso, he was a researcher. He was in Mexico, and based in Mexico. He died in 1970. His major contribution was the discovery of 3 correlation dates that match up when we count backwards from 1 Coatl. 1 Coatl is a very, very, very important date. That's the date of the fall of Mexico-Tenochtitlan. And all of the Spaniards, all of the native writers, everybody who documented that day, they all said it happened on 1 Coatl, and that corresponded to August 13th, 1521. They were using the Julian calendar back then. So if you want to know what that would be in the Gregorian, you would have to add 13 days. So look, if you want to convert from Julian to Gregorian, you add 13 days. So we can go at 13 and we'll get to 26. So in the Gregorian, August 26 would be the corresponding date. And here's the thing about Caso. He did a lot of research on the calendar. He did a lot of, one of the first meta-analysis, because there's so many sources that talk about the calendar, he kind of just synthesized all of that, and he did some amazing work. And he said, okay, this many said this is the start of the calendar, this many said this is the start. And so he made a huge contribution to the field. Now, here's the thing. In my opinion, and people may disagree with me, I don't think that, when he died, like he felt like he had a functional calendar. Like if you were to ask him, hey, is that a functional calendar? He probably would have said, no, it's not a functional calendar, because he just did research to like correlate it to Spanish dates, but he didn't necessarily make a calendar from there. This happened with people after the fact. People after the fact looked at his dates, and then and they started to make a calendar, and then they called that the Alfonso Caso correlation. Now, here's the thing. So these are the dates that he came up with, and I'll show you what that looks like on a calendar. But basically, the 2 most important dates are the arrival of Spaniards into Tenochtitlan. That's a very, very reliable date because, again, all the natives, this is a very monumental event, right? So they all wrote it down, and we know, oh, they all have the same dates. Because with other dates afterwards, there's not a lot of agreement anymore. people are, one person says it's this date, another person says it's this date. So we don't know. There's no agreement. And so that's why these two dates are so important, because there's 100% agreement. Everybody agreed this is the date. So it's 8 Ehecatl, or 8 wind, in the Tonalpoali. This is the date that they arrived. And we have the year 1519. And then of course we have the Spanish date. And then the last one is the fall of Tenochtitlan. So in 1521, on the date 1 Coatl, it fell. Okay. There's also the Xiopoli, the actual month. I'm not going to talk too much about that yet, because it's a whole different conversation that I mean, I'll talk a little bit about it later, but as far as like the correlation, I'm just going to stick with the tonali. That way it's simplified and we can understand where I'm going with this. Okay. Now, here's the thing that is the critical fault with this correlation. Okay. He did not incorporate a leap year, which resulted in his calendar moving 120 days. And so, again, I don't think that Caso, thought, oh, I have a functional calendar that coincides with the one of Mexico-Tenochtitlan from 1521. I don't think he thought that. After the fact, people said, oh, let's just use this and count from there, and we'll have the same calendar correlation. What people don't understand is that we need a leap day every 4 years. And I'm going to show you why. The solar year, okay, is, let's see, here it is. It's 365 days, but it's plus 5 hours, 48 seconds, and 46 seconds. Okay. And so the problem with that is our calendars are only measuring one full day at a time. And so this is the number I was looking for. This is the decimal version of what I just told you, the 5 hours and 48 minutes. And so what happens here is the actual solar year, the time that it takes the Earth to make a complete revolution around the sun and end up in the same spot that it started with, is not a whole number. It's not 365 days. It's 365.2564 days. Okay, and so what happens is, and just like my previous one, my previous video, I'm just gonna go slow with it, so we're really understanding what I'm talking about here. Okay, hold on. I have to memorize this, or the calendar. Okay, hold on. Let me go back here. There it is. All right. So look, 0.2564. Let's say that 2 years have passed, right? And we're following our calendar that has 365 days. So that's going to be times 2. That means that our calendar after 2 years has trailed off a half a day, because 0.51 is, like, you could think of like 50% of a day, right? And so since it's half of a day, there's no error yet. Like, nobody will notice an error, because nobody's tracking it to the decimal, right? There's nobody doing that. We're using whole numbers, whole days, and that's the case for everybody in the world. Now, let's see, 2.564. If we multiply that by 3, so now we have 3 years of following the solar year, and so that's going to be 76 or 77%. We rounded up, so 77% of a day, okay, has accumulated an error. But again, our calendar is one whole day, so therefore nobody's going to notice that. It's going to be fine. Everybody's going to say, all right, that's great. It's not until you get to the 4th day where it's noticeable, and we say, okay, there's a problem. Now here's the Europeans knew about this. They did not know how to correct it though, and it took them a very, very long time, hundreds of years actually, to correct it. So their calendar, you know, because the Julian calendar was formed in the Roman times. I believe it was Julius Caesar, which is why it's named the Julian calendar after him. He started it, and then they followed it. They said, "Oh man, it's trailing off every year," but they didn't correct it until the 1500s, and then so their calendar was was not accurate, and so that caused a lot of problems. But here's the thing: you multiply by 4, and now you see an error. Look, one full day. Okay, there's one full day of error because we only have 365 days, and using whole numbers. Our ancestors utilized sunrise to sunrise as a full day. Okay, so that's the way they did it. And so that's a whole number, right? So there's no fraction, there's no decimal there. And so after that 4th year, I'll show you what would happen, because this is my weekly planner, and somebody had asked me about this. And the weekly planner, they said, "Wow, how come there's?" Because these are the last days of the year 2022, and so they asked me, "Well, how come you have 2 10 shochi days? You know, well, why aren't you starting the? Because this is the symbol for the new year." They say, "Why aren't you starting that on the 21st, right?" Well, that's the thing. Like I said, every 4 years you have that one extra day. Okay, and the reason for that is because when you when you are adding a day of correction, what you're doing, let me see if I can type it in here. What you're doing is you're adding 0.25. Okay, so you're adding 0.25 by adding this extra day here. Okay, and so you're adding 0.2, because this is a whole day, yeah, it's a whole day. So you can think of it like, okay, the whole day can be divided 4 times, right? 4 times. And so 1 2 3 4, and then that's going to cover until the 4th year, and then it's going to require another, what we call an addition of a leap day, because that's the leap year. And you have to do this to keep it calibrated, because there's that extra day of accumulation, and this 0.25 day covers that, so that this one extra day does not mess up the calendar. Now let's think about it for a minute. If we did not add this leap day, right, what will happen is, okay, there's a year, there's a day accumulated because of how the solar year works. So you're gonna have this extra day, and we put the new year here instead. This is a 11 alligator. We put it here. What that means is our year is starting one day earlier than it should, right? So we can see that it's one day earlier, and so that is the result of the error. A calendar is accurate only if a certain point in the calendar, in this case we're measuring the 1st year, occurs at the same exact time year after year. If that does not happen, then your calendar has accumulated error. And I'm going to show you on the Caso calendar how we can see that. At this point in time, the Caso calendar has trailed off 121 years exactly. Okay, so let's go over here. So here's how we can estimate that. So look, we go year 2023 minus 1521 equals, okay? And so that's going to be 502. Now we're going to take that number divided by 4. And this tells you about how many days Caso's calendar is off. As you can see, it's a huge amount. It's 125 days. So let's take a closer look at how that happened, and we'll use the Aztec calendar website to look at today's date, March 20. Okay, so let's look at today's date here. So we have January 20th. Okay, so today is 7 Ehecatl. In the AztecCalendar.com website, the correlation is Alfonso Caso. Again, no leap year, no leap day has been added. And so let's look at what the actual calendar says. This is based off of my website that has the correct correlation that aligns to the calendar in Tenochtitlan. At the time of the conquest, this is the Ruben Ochoa correlation. And the day is 3 Cipactli. Okay, so 3 Cipactli and 7 Ehecatl. So let's go ahead and check and see how much error that is. Okay, so let me get my highlighter here. And so again, we said 7 Ehecatl and 3 Cipactli. Okay. So as I showed you in my weekly planner, if you don't add that extra day, the leap day, what's going to happen is it's going to shift. It's going to shift backwards, right? And so what has happened here in the Caso count, we're supposed to be here, but we went backwards, okay, all the way until we got here. Now, if you count, you can count by column. They're like they're actually exactly 20 days by column. So let's go ahead and see what we got. 20, 40, 60, 80, 100, 120, 140, 160. Okay. And so you can see the amount of error here based off of just counting from one end to the other. And so it's substantial. This is a substantial amount of error. And you can go by, I was just estimating, but you can go count day by day, and you're going to get a number that is very, very close to this number. Okay. And so that is the problem with this calendar. It's just way off. Now, I'm using the Ruben Ochoa correlation to show you that. So I know a lot of people will be like, well, how do we know that the Ruben Ochoa correlation is correct? Well, in a very quick summary, I will say that the Ruben Ochoa has a leap day, like I showed you in my weekly planner, for every leap year. So the accumulation is not does not exist. And so we know that's the day. But that's not enough. I'm gonna prove to you that that's the day. I'm gonna go back to Alfonso Caso's research. Okay, so at this point, you just have to trust that what I'm saying is true. But I'm gonna actually show you now, and I'm gonna prove to you that what I'm saying is true. And so what I'm gonna do is I'm gonna search for that day that I showed you, arrival of the Spaniards. Okay. Arrival. There it is. So I told you the day was 8 Ehecatl, and I told you the day was August 11th. Okay, so that was here. Okay, August 11th. So here we have that. Actually, that's actually not August 11th. Sorry, this is these dates are like in Mexico style. This I do it in Mexico, so it's actually November 8th. Okay, so November 8th, and then going back here, this is November 8th. So that's the Spanish date, and so we can see this is when the Spaniards arrived. Critical date. Caso confirmed this date is completely accurate. Now, the other date that I told you was the fall of Tenochtitlan. So here it is here, the fall of Tenochtitlan, one Goat. Now this one is the August. Okay, so it's August 13th, right here. Okay, so that was the fall of Tenochtitlan. And so two very important dates. Now I put these dates side by side like this so you can see the Spanish date and the native date. Now here's the crazy thing. Caso had these dates. He knew what the correlation was. He knew that one Goat had to fall on August 13th. And the crazy thing is, the only way to get from the first date, the arrival of the Spaniards, to the fall of Tenochtitlan on these exact or in this case, the Julian dates, you have to add a leap day. And so let me show you. Okay, so again, Caso was a smart guy. He was not, I mean, like I said, a lot of his research is valuable, and so that's why I believe that he did not even bother to double check, like how I charted it here. I don't think he ever did that, because if he did, he would have seen you cannot get from one of his dates to the next date without adding a leap day first. If you don't add this leap day, you can't get from one day to the next. Okay, and so that's the critical error that people are not understanding with Caso. They're starting there and they're just moving without the leap day. But this is showing us that his own calendar dates, his correlation dates, do not even match up unless you do this. So we know there has to be 2 days repeated. I mean, this is an absolute necessity. Okay, and so again, just following the math of his correlation dates, it has to be that way. And there's other evidence and things for the leap date, but I'm just gonna stick to Alfonso Caso's correlation date, because this whole video is about Alfonso Caso. And so we know we have to have a leap date, and so we know that's how they did it. Now, I'll just say this, scholars, they have all kinds of different theories. Some of them will say, oh well, they didn't add the leap day, like how I showed you, right? They probably just corrected the calendar every 52 years. It's like every 52 years they're gonna correct it, and so they just have a bunch of ideas, right? But it's not really based on anything real, because if any of these people understood the causal correlation dates, they would understand what I just showed you. You cannot get to one without the other. And just like I showed you with my weekly planner here, right? The day will shift up. And so what would happen if I did not add this date? Okay, when we get to the fall of Tenochtitlan, this fall of Tenochtitlan, one Goat would not be on this date, right? It would actually be on August 12th, which is the wrong date according to his own research. Okay, and so leap days are an absolute must. So let me go back to the next part here. The other thing is, if you're looking at the Aztec calendar, and I think this is one of the reasons why a lot of people just don't understand this basic principle, is because it's a complicated calendar. It's not straightforward, because, for example, like if I say, okay, one Cipactli is the beginning of the year, which if you haven't seen the previous video, you have to watch that to understand this, because these videos build on each other, and I went in detail talking about these starting dates, and so you have to watch that in order to understand this. So go back and watch it if you're confused. But the starting date, 1 Cipactli, this is the starting date of the year. Well, look, the next year is not 1 Cipactli, right? So if you look for 1 Cipactli here in this year, it's going to be somewhere in the year. So we cannot say that 1 Cipactli is going to be in the same position every year. The way we have to do it is we have to look at the year 1 Ehecatl specifically. And so that's the other thing that complicates it, because you have to understand that pattern. So what we're doing is we're looking for a 1 Ehecatl year in which this 1 Cipactli is in the exact same position as it was in this 1 Ehecatl year in 1519. And if it is, then you know your calendar is correlated. If it's not, you know it's completely wrong, which is the case with Caso. So let's start with 1 Cipactli. And once again, those of you wondering, well, where did that date come from, right? I'll go back to the arrival of the Spaniards. So they arrived here on November 8th, okay? And so what I did is I counted backwards, okay? So the day before 8 Ehecatl is 7 Cipactli, 6 Xochitl. And I put this in a spreadsheet to make it a little easier, but so I just counted all the way backwards. And as I stated in the previous video, we know this is the first day of the year. So what I'm going to do is I'm going to show you 1987, okay? Because 1987 is also a 1 Ehecatl year. So if you want to, again, see if your calendar is correlated, you have to look at the same year. You cannot match up a 1 Ehecatl with 2 Tecpatl, because they're completely different day signs. So that's not going to work. And so what I did here is I went ahead and put this date for 1 Ehecatl into the AztecCalendar.com. So this is March 25th. This is March 12th. So once again, 12 plus 13 is 25, right? So that is making the correction from the Julian, or the conversion from the Julian to the Gregorian. And so look at this date. It's 13 Olim. This is the date. It's supposed to be 1 Cipactli. Well, let's see how far away that is. One Cipactli is here. 13 Olim is way over here. So once again, the error has accumulated. We're going backwards. You go backwards, as I showed you, and it's going back. And so Caso's date, it should be this. It's actually this. So that simple exercise tells us it's completely wrong. It's nowhere close. Now, I'm basing this off of the Gregorian date, which is another a huge error that everybody studying the calendar makes. Okay, look, they're like, all right, 1 Cipactli is supposed to be on the Gregorian date, but here's the thing: the European calendar is based off a completely different system. Our system is based off of the observation of the sun. Their calendar is based off of a mathematical equation that Julius Caesar came up with, in the Roman times. And so as a result, the two calendars do not match each other. The Aztec calendar does not match up with the Gregorian calendar. And I'm going to prove it to you right now, because I'm going to go to 1987, which is, again, it's the year 1 Ehecatl. If you missed that, see, 1 Ehecatl is the solar year. So that's what we're talking about. I'm gonna show you in the Ruben Ochoa correlation, the correct correlation, what that date looks like. Okay, so again, we're going to 3/25/1987, which is the same date as this Spanish date. Okay, so March 25th, 1987. I believe I have it set up already somewhere. Maybe not. Oh, here it is, maybe. Okay. So March 25th. So check it out. March 25th in our calendar now is 4 Quetzalcoatl. Now look, this is not 4 Quetzalcoatl. Look, 4 Quetzalcoatl is here. So people might be saying, well, that doesn't match either, right? What's happening? And yeah, it does not match the European calendar. But that's the mistake here. If you use the European calendar to correlate it, you're going to be wrong no matter what. Even if you count it correctly and incorporated a leap year, a leap day, it's not gonna match the Gregorian date. But here's the thing: we're not trying to match the Gregorian date, right? This date trails off. It does not match our native calendars. We're not using a astronomical phenomenon to anchor their calendar, and so we have to get away from that. Ruben Ochoa always says, like, I don't even look at the Spanish dates. Beyond the calendar, those two correlation dates, there's no reason to do it, and it's just going to confuse you and mess up your work. And so here I'm going to show you then how we did it, how our ancestors did it. Obviously, before the Spaniards came, there was no Gregorian, there was no Julian or Gregorian calendar, so there's no way that they matched anything to that, right? And so this is what they did instead. They used the spring equinox. Okay, so we know that because the starting date, Huancipatli, just happens to be after the observable spring equinox in Mexico. And so I'm going to go to 1519 to show you what I mean. So in 1519, March 11th, that's when the spring equinox was visible. Okay, in the morning of March 11th. Now watch this. This is March 12th. Okay, this is Ruben Ochoa's major discovery. The year starts one day after the observable equinox. So going back here, our ancestors, they went to the astronomical shrines called, today they call them pyramids or Teocalli, and they went there and they saw in the morning, oh, it is the spring equinox. And they could tell because they had these markers, very precise markers, and observation tools as well in order to. So these sighting devices, they're well documented. They're all throughout the codices. You can see them, and they were most likely had some kind of obsidian glass, in order to protect them from the glare of the sun, and in order to make a very precise determination of when the spring equinox occurred. And this is just an example of what it looked like. And listen, there are buildings all over Mexico. Okay, so this is just an example from a reconstruction from Tenochtitlan. Okay, and so this is what it would have been like. The priest would stand here, and this is explained in the documents as well. They would stand here and they would wait until the sun reached that point at the marker, and in this case, it was right between the twin temple of Huitzilopochtli and Tlaloc, today called the Great Pyramid of Tenochtitlan, or the Templo Mayor. And so once it hit that exact spot, then they would know it's the spring equinox, and they would then start the day on their new year on the next day. And we know that because we count backwards from those critical correlation dates that Caso discovered, and we see the year starts on those dates, one day after the spring equinox. And once again, if you see the previous video, you will see how we know that this date is the is the first date of the year, and that's using purely pre-Columbian sources. So there's no confusion. It's completely the sources and evidence is very tight with that. So this is the first date, one day after the observable spring equinox. So that is then our anchor point. Okay, we're not dealing with these Spanish dates, because I've already showed you that the error accumulates if we do that, and we don't want that. So we're supposed to have one Cipacli, not on March 25th, but on the day after the spring equinox. And so let's check it out. We have, going back to 1987, because that's a one Ehecatl year, the spring equinox happened on March 20th, but it happened at night. And our people are tracking the sun, right? And so a lot of people get confused with this. We're not, our ancestors could not see the spring equinox. If you're tracking the sun, there's no sun, it's nighttime. And so a lot of people get confused. They say, oh, but, it should be the day after this, but it's actually not. It's the day after March 21st is when our ancestors would have seen the spring equinox, right? Even though it occurred at night, they don't see it until March 21st. And they say, oh, okay, there it is. And so that means that March 22nd is the day after the spring equinox, and therefore that's the start of the new year. So I think I have that one. Oh, I had it here, but let me go back. So look at that, just like that. March 22nd, the day after the observable spring equinox in Mexico, we have one Cipacli. Isn't that beautiful? And it's the same exact date. It's the starting date of the new year. And this is how we know, this is all the evidence that we need to know. It is completely correlated to the calendar of Mexico-Tenochtitlan. No other calendar correlation can prove that. Let me show you the 1987 date for the Caso count. Okay, so once again, I said that we're looking at March 22nd, 1987, because that's the day after the spring equinox. So let me change this to March 22nd. And as you can imagine, it's going to be off by quite a bit still. Okay, so we have, what is this, 10 Jaguar. And so if we look back at my chart, and all of these resources, again, as always, they're all available for free on my website. We're going to go find 10 Ocelot. 10 Ocelot. This is 10 Jaguar. There it is. And so again, it's supposed to be one Cipacli. So we went backwards, not forwards. We went backwards 20, 40, 60, 80, 100, 120, 140. Okay, so something like 140 something days based off of this. Okay, and so that's the accumulated error of the Caso count. That's the other thing. This website doesn't even have the accurate accumulation of error. I mean, even the error is an error, right? Because if we did the math, it's supposed to be like 125 or 121 days, right? But it's even more than that. So not only is the Aztec calendar wrong because it didn't have the leap year, but they did some kind of calculation error, and they made the error even more than what it should be. So this 10 Ocelot, we can see very clearly, is not even anywhere close to one Cipacli. And so this is how we know the Caso correlation is completely off. And, I wish people would stop using it. I hope that this video has helped people to see, how ridiculous it is that scholars and, cultural practitioners are still using this calendar when it's not even a complete calendar. And the error is just a tremendous amount of error. It has nothing to do with the calendar of Mexico-Tenochtitlan. And so I see more and more people citing and using the Caso correlation, which is a red flag. If you see somebody using this, they don't know anything about the calendar. They're not at all. Because if we're correlating the calendar, we're utilizing observable phenomenon such as the spring equinox. You can also use the winter solstice. In one Ehecatl, for example, there's a source that says that the winter solstice sun happens in one Ehecatl. Okay, let's see, on the day 4 Olin. So let's see, I have all the Olin highlighted. And so one Ehecatl is another correlation date that we can use because it's cited in the pre-Columbian sources. Okay, so this is 4 Olin, and you can see, just like I did with the spring equinox, you could do your own research with that, and then look at where 4 Olin should be in this year, and then use that as a correlation date as well. And that would just be further evidence. And just to summarize here, this is what I talked about regarding the Caso correlation. So it's not a complete correlation. It's not a complete calendar. It does not have anything to do with the calendar in Mexico-Tenochtitlan. People after the fact utilized Alfonso Caso's research and counted from where he left off. And it does not contain a correction that all solar calendars require to keep the calendar synced to the path of the sun. Okay, so there's no correction. Each tonali has trailed off exactly 121 days from where they should be. Itztli, the Aztec month firmly linked to the winter solstice in December, occurs in August in the Caso correlation. And so I told you I'd focus on the tonali, the tonalpoali, but Caso also he wrote down his what he thought to be the correct correlation of the months as well. And so he was way off with that, because we know Itztli, it has nothing to do with August. It has to do with the winter time. It's all about the birth of Huitzilopochtli and the birth of the 4 Olin sun. And so as a result, it has nothing to do with August. And so the other one is Tlacashipa-Walisli, which is supposed to occur in the spring. Well, for him, it's a few months before as well. And so his months are way off as well. So that's another thing about the Caso correlation that we need to be aware of. Basically, nothing about the correlation is accurate at all. This is the one that can be found at azteccalendar.com. So please, if you see somebody using it, educate them and try to lead them to the correct correlation. You can show them this video. And like I said, there's been a lot of great dialogue. People have been asking some great questions. So please, if you have any other questions, feel free to ask in the comments of this video or through my Patreon. I have a Patreon account. If you appreciate this work, my research that I'm doing and sharing with you all, please consider becoming a patron. And yeah, thank you very much for watching. And I'll see you all next time. Like I said, I'm going to make a kind of like a calendar series. So next time I'll tackle another popular correlation. And then hopefully as we debunk them and learn about them, we'll also learn about the correct correlation as we go as well. All right. Thank you very much for coming. Tasa Kamati. I'll see you next time.